Trig review number 4, inverse trig functions. When we're doing inverse trig functions, if you recall from the first three, we've always been finding the cosine or sine of an angle, of a given angle. Right now, we're going to try to find the angle given the cosine. So just for start, I just want to make sure in your calculator you know how this works. So we're going to type cosine inverse, which is second cosine, parenthesis -1/2, and make sure your calculator is in degree. You cannot be in anything else but degree. So get that in your head. You need to be in degree mode for trig. Okay, if I type this in my calculator and press enter, it returns 120, and that's degrees. So when I'm using the cosine inverse button, the inverse of cosine, I am putting in sides and getting out an angle. When I am using the cosine button, I am putting in an angle and getting out the side ratio. So continuing with the second one, if we go ahead and put that in our calculators, I'm going to get, rounded to 3 decimals, 54.736 degrees. Okay, so say we have a problem like the one on the bottom left, where I'm trying to find theta, and I'm given both the legs. Okay, I want to find theta. I am given the opposite of theta and the adjacent of theta. So I can actually use the tangent and say inverse tangent, because I'm going to plug in sides, opposite over adjacent, and that's 2.5, is going to give me an angle measure of -22.620 degrees. Same thing here. I'm giving the opposite and the hypotenuse. The opposite and the hypotenuse is sine. So if I use the inverse sine and put -8 over 82, I get -5.599 degrees. Okay, be careful, I'm talking about inverse trig functions, meaning the inverse of cosine button, the function inverse, as opposed to the secant is 1 over the cosine, so it's the inverse of the cosine. Two totally different things. This is not what I'm talking about right now. So we run into a problem when the question is asked, find an angle whose sine is 1/2. Well, if I go ahead and press sine of 1/2 into my calculator, and make sure I'm in degree mode, so inverse sine 1/2 is going to give me a 30-degree angle. So I start by saying, okay, what angle has a sine of 1/2? And it gives me back 30-degree angle. But as we kind of looked at yesterday, here's my 30-degree angle, so it's going to have a sine of 1/2. Well, this reference angle is also 30, so this reference angle is 30 over here. This reference angle is also 30, so does it make sense that the sine of 150 is also 1/2? Well, then this reference angle is also 30, but is it also 1/2? Well, I know that this sine would be -1/2, and this reference angle would also be, the sine would be -1/2, but then I go all the way around. So what if I did this? 360 plus 30, doesn't 330 degrees have a sine of 1/2? Let's write that differently. So isn't the sine of 330 also equal to 1/2? So typically you are told a range of angle measures that you are given so that you can narrow it down to one. So I want you to remember back to the worksheets from last night when we were talking about quadrantals, and on the video that, yes, the audio was about 12 seconds ahead. So we were talking about quadrantals, and my quadrantals are all of these angles that end at an axis. So this would be 0 or 2 pi. This here is pi over 2 or 90. This is pi or 180, and this is 3 pi over 2 or 270. So notice I'm doing it in radians instead of degrees. And we talked in my class yesterday how sine in quadrant 1 is always positive because the y is positive and the radius is positive. So let's just go through that one more time in case Ms. Future didn't go over this yet. So typically when you're finding sine on an coordinate plane, your sine is the y over the radius. Your cosine is the x over the radius, and the tangent is the y over the x. And this will all pull together when we bring in the unit circle. So I know that my x and y are positive in quadrant 1. So I know sine is positive here, in here, cosine's positive here, and tangent's positive here. Okay, if I go to quadrant 2, I know y is still positive, so sine is positive. Cosine is, my x is negative, so cosine's going to be negative and tangent's going to be negative. In quadrant 3, I know I now have a negative x and a negative y, so sine and cosine are going to be negative, but tangent's going to be a negative over a negative, so it's going to be positive. And lastly, in quadrant 4, I know that sine is negative, my y is negative, so sine is negative, but my x is positive, so my cosine is positive. Tangent is going to be y over x, so that will be negative. Now, how do people remember this? All in the first quadrant, students in the second quadrant, take in the third quadrant, calculus in the fourth quadrant. That's how we remember which trig functions are positive in which quadrant. Now, the next thing I want to talk about then is this whole issue of how many angles have a sine of 1/2. Well, you could put in, like I said, you could put in sine of 30, you could put in sine of 150 in your calculator, you could put in sine of 330 in your calculator. They all have sine of 1/2. When I'm asking sine of 1/2, I'm typically restricting myself to quadrant 1 and quadrant 2, because this is where my sine goes from 0 to 0, taking in all the positive and all the negative accounts. So sine is usually restricted from negative pi over 2 to pi over 2. So using that same fundamental, typically we will only talk about finding cosine from in a range of 0 to pi. So 0 is less than theta is less than pi. And for tangent, tangent goes from negative to positive in the same place because I have a positive cosine and a positive sine, or a negative cosine and a negative sine, which will both be positives. So this would be from negative pi over 2, theta, positive pi over 2. So what does an example of something like this look? So find sine of theta is negative 0.71, but I want to know for which angle between 270 and 360. So if I put inverse sine of 0.71 in my calculator, negative 0.71, I get negative 45.235 degrees. But that's not an angle between 270 and 360. negative 45 would be here. So they actually want it to be read this, because 270 to 360 would be here. So this would be approximately 315 degrees.